Okay, welcome back. Are we ready to jump into it? Get some stuff done? Main things for this week that we're working on is get onto discussion board, like posting something. So make a GitHub account and then post something on our discussion. And then quiz 0 and then homework 0. So homework 0 is loading up Jupyter and Python, and quiz 0 is practicing like doing the quizzes. So for this one, we'll go through it together, but for the rest of the quizzes, we'll build them together and then you do them on your own. Sound like a plan? So I think usually GitHub, there's not too many, but if there are issues like making a discussion post or anything like that, let me know. But I was going to jump into quiz 0 first and then look at getting into NanoHub and Jupyter next. Good plan? A plan? All right. General structure, at least the way I formatted Husky CT, is like quiz 0 folder, and then there's a link to what is quiz 0 and then how to submit, like where you put your stuff for quiz 0. Oh yeah.
The quizzes, you need to like print out the quiz, or can you do it like a separate piece of paper, or can you do it like electronically online?
So I can show you at least like I can show you how I would do it. So if you want, you can print it out and then work on the page, or you can just use a sheet of paper and then scan that sheet of paper and send that one in. So in this one, we have Spider-Man, surprise, and he's swinging. So and he's carrying some kind of bad guy. So in the image above, he's swinging. Draw a free body diagram. So this is the bread and butter, and we're gonna keep drawing free body diagrams all through the semester. There's nothing else that comes out of this class. It should be every problem starts with a free body diagram. Yeah.
I have two questions. When I do my free body diagram, I do Spider-Man and the guy is one system that.
Oh, you lumped the masses together?
He's holding on to.
Okay. Yeah.
Is this like really like accuracy and stuff?
I mean, mostly it's seeing like where you're at for free body diagrams. So that's okay. Yeah.
My second question was I looked through the Python review homework thing, and I wasn't really sure like how to submit actual work and code and stuff.
Oh, okay, for that one, and I can show you how to do that when we get to that next. But to answer that question, main thing is when you have a Jupyter notebook that you've done, click print preview and then save that. Print preview will show you like some kind of website, like all of your inputs and outputs, and then say save as PDF, like print to PDF somehow.
So the Jupyter is the platform where you write the code and
yeah.
You save it. And then, okay.
Yeah, so then you create like a static print preview of whatever you did and save that as PDF. Yeah, ideally we could just like send notebooks back and forth, but oh man, does Husky CT not like Jupyter notebooks. It's like has no idea what to do with it. Sometimes it flags it as like this might be malware. Like technically, I guess you can make but you can make a PDF malware, right? Anyway, okay, so quiz 0. We were just so one of the questions that came up was like, how do I include that bad guy? Like, there's a bad guy. There's got to be some kind of force. So I'll show you at least my thought on this. Do some of this. So we got. I'm gonna do like point mass. So just like, I'm not gonna consider the moment of inertia of Spider-Man and how the bad guy is changing that. I know there's some kind of like web tension on Spider-Man. I could label it web. I know Spider-Man weighs something. Like there's some kind of weight due to him not being a massless particle. And then there's something from the bad guy. So one thought was add bad guy weight. Does anybody else have a thought on that? If you're looking at this, would you just add the weight of the bad guy to? Yeah. Add the weight. So we could have like, we could draw 2 arrows, right? W bad guy, something like that. And that way we know that both of those weights are kind of going down, something like that. This is assuming that they're like lumped together very much the same mass. Just mass plus mass is now new mass. Another way is maybe I would draw like some kind of internal force. Like I know Spider-Man is holding onto the bad guy, but I don't know what force he needs to hold onto the bad guy. Kind of roughly makes sense. So there's some kind of internal force where Spider-Man is creating something, or the bad guy's like creating a force on Spider-Man and he's like overcoming that force. That's another way that we could think about that. And it's got to be directed either towards or away from that bad guy somehow. Yeah, and then, because if I look at like the actual bad guy, there's some kind of force from the bad guy to Spider-Man and the weight of the bad guy. So overall, it adds up to the same free body diagram. It's just, do I want to consider them? Do I want to know what that force is, or do I not care? Do I want to figure out what the force and the tension is? Do I want to figure out what the force of Spider-Man's hands are? Like, there's a lot of ways that we could draw this. And it's up to you, however you want to do it. Cool. Yeah.
So I noticed that isn't it centripetal force? So how would we represent that?
Ooh, so centripetal force? Yes. Or centrifugal force?
Centripetal.
There's a centripetal acceleration, which creates a centrifugal force. Is that what? Yeah. And again, this is like super pedantic, but that's what we're here for, right? Is like the details. Yeah, Richard Feynman, in his introduction to thermodynamics, he says like, thermodynamics is easy. Energy is conserved, entropy increases. We leave the details, all the complicated details, to engineers. It's like, that's what we have to deal with. It's all the complicated details nobody else cares about. All right, so if we want to say there is centrifugal force on Spider-Man, because right now, some of the forces is not 0, right? Something's happening. There's got to be acceleration. The forces are not aligned with each other. Even if I just add, even if all I did was say T, and then W plus W bad guy. Like there's an overall, the force is moving somewhere. There is a force. And this is my like highly, I'm gonna say suggested, but really it's like highly suggested, is always keep forces and acceleration separate. So here, the big tool that you got from like statics is free body diagrams. The new tool that we're working with here is called kinetic diagrams. So always, always, always just like keep those two things separate. If you're talking about changes, so centrifugal force and centripetal acceleration, those are very much it's always a change in momentum. Like somehow there's an acceleration term in there. So then I would have like a mass times radial acceleration, which, and that one's going to be that mv squared over r term, that centrifugal force. And then also like some kind of like theta of like this, because the t and the w are not lined up, there is some acceleration. All I'm asking for is the free body diagram, just identifying forces. But if you're trying to say like, all right, I know that I want to include centrifugal force, I would highly suggest keeping it separate and saying like the forces equal centripetal acceleration. That's why high school physics teachers, did they like yell at you a lot about, mine did, there's no such thing as centrifugal force. It's only centripetal acceleration. It's like, well, it exists. There is a centrifugal force, and we use it all the time. Like it's constantly used, and it's a very effective means of applying a force. It's just that it's always like a momentum base, like it's always based on reference frame. So you just have to keep that in mind. So it helps to keep them separate. Free body and kinetic diagrams that way. Cool. That was longer than I thought we would take on it. But that was a good discussion, like getting started. So that's our problem number 1. And now problem number 2. It says write down Newton's second law of motion as an equation. This one, usually we write it down like F equals ma, right? I'm going to put it as vectors too. Whoa. So this would be first part of the quiz is a PDF of this. So if I wrote it out on a piece of paper, I would scan it and then add a PDF of that. If I did it on a tablet, then print that to PDF. Then the next part is like a reflection. It can be an audio recording or a video recording about like, is everything the way you expected it? Like you understood everything? Is there anything you're not sure of? Or is there anything that like you definitely didn't get and you're just sort of guessing? So a quick 10 to 30 seconds can be audio or video. So I'll give my example here and now. Ready? So we'll say 3, 2, action. This is my submission for quiz 0. I drew 2 different free body diagrams, and I wasn't really sure which one to use because I was thinking about centrifugal force, but I didn't know how to add that in. So in the left one, I have Spider-Man and the bad guy as 2 different free body diagrams with tension and their weights and some internal force. But then under that highly suggested, I have Professor Cooper's like kinetic diagram, which I don't know how to use yet, but I'm putting in that mass times acceleration terms to try to write out that centrifugal force. For number 2, that one I'm sure of. F equals ma, that's Newton's second law. Cut. So that would be like my maybe 30-second video reflecting on this. Cool. that one is kind of dual purpose. One, reflection is like one of the critical parts to like actually learning something, like thinking about what do I know now? What do I not understand? So just taking that like 10-30 seconds to think about it, say it out loud is really helpful, like as you're thinking about what you're learning in this class. The other part is more logistic and like stamp of approval UConn stuff, is that if you're doing online testing, sometimes there's a check of how do you know the person that turned this in is the person that they say they are. And it's like with an audio or video recording, I can say like, leave me alone. There's this like reflective piece and the students are thinking about the assignment. So it's dual purpose. One is actually helping you learn something. The other one is so that no one can bother me about online identity verification. And we don't need like a Big Brother monitor. What are those things called? I forget what the testing software is, but they drive me crazy. It's like Big Brother 1984 style. Yeah.
So all quizzes, we need to like submit a recording of ourselves going through the problem.
Yeah, and it doesn't have to be like going through, like you don't have to go step by step of like, this is how I approached it, but a quick litmus test of like, part one, I was sure of. That made sense. Part two, I don't know. I'm trying, but this is the piece that I didn't understand. Or it might just be like, I completely guessed and I'm hoping that it's right. And that's also good information for yourself and for the TA trying to give you some pointers or ask questions, like help improve on this learning journey as we go on together. Quiz 0. Good. Yeah.
What does R stand for again?
That one, I'm just using R as like some kind of reaction force.
Oh, okay.
So like internal reaction force. Because I know Spider-Man is holding bad guy, and I know bad guy. Because if that force wasn't there, bad guy is falling.
Yeah.
So there has to be some force on bad guy. And I know that if there's a force on bad guy, then Spider-Man is the one creating that force. And it's always equal opposite. Yeah.
In our submission, we have to include the kinetic diagram for this one, or since we haven't really like learned.
You don't need a kinetic diagram, but the question came up like, how do I include centrifugal force? This is my highly suggested centrifugal force edition. Like if you think that is the driving, and it is, right? Like if you're swinging on a swing, it's not fun because there's a tension and gravity. It's fun because there's like centrifugal force. Like it's the cool part. That's the mv squared. And it's the easiest one to like increase, like the most acceleration, most bang for your buck. So if you want to include it, try kinetic diagram. If not, just identify what are the actual forces involved. I've seen other people adding like wind, like some kind of wind resistance or drag or something. Wind tunnel, some kind of forces. Cool. I know I said the class would be like a lot of hands-on doing stuff together. Today is a lot of like demo stuff of getting up. But once we're in the flow, then we can jump back and forth a little bit more. All right, so that's quiz 0. Getting up, doing it, submitting some kind of reflection piece on that. Now homework 0 is going to be our first like Jupyter assignment. And this one we also have to do some logistic stuff because we need to get into Jupyter. So up in that like rocket button, there's a thing that says Jupyter Hub. And if you click that link, it'll bring you to NanoHub. NanoHub will run Python and Jupyter for us. but you need an account to actually use it. It's a personal account, so you'll have access to this personal account forever, or until you delete the account or something. Or Purdue decides to drop NanoHub. But as far as I know, they're like another decade or two of planning, of like upgrades and all sorts of stuff. We have. Oh yeah, let me do this, because right now I'm logged in. So I'm going to say open in incognito. If I try to launch the tool, it's going to tell me like, hey, you need to log in. Don't use that first button. Don't use university credentials. It just doesn't work. Google sign in does work. So if you have a personal Gmail account, you can probably use that one, or you can create an account. So if I create an account, then need a username, make a password. I need an email. And then I think the rest of this is all optional. Oh, except for organization. I feel like Bruce Wayne's pretty private. And then had you here at it. From an instructor. And again, you could do something else if you want. Run simulations, and that's fine. So all that, agree to make sure you're not a robot, make sure you agree to terms and conditions. And then I think it'll send you like a verify email of like, yes, this email does exist. The one that I typed in doesn't exist, but the one that I do log in with does exist. So once you do all that, it'll bring you to I think it'll just like drop you right into either this main website or your dashboard. So you'll end up in one of these two places. But you're logged in and you have access to all these resources, and there's tons of other like NanoHub tools and resources and all sorts of great stuff. So if you do want to explore, now you have access to it. Most of it's funded through like NSF and DOE kind of funding, so lots of interesting like science and research. Yeah.
You know how I can add the meetings to my sessions? I don't have that.
Yeah, so it's not going to be there to start. So your sessions are just going to be empty, right? So go back to our homework 0 or any website page where the rocket button is up there. And now when I click that launch in Jupyter Hub, I can tell it to launch that tool. And now I can get up into the website, like up into Jupyter and run that. So a couple of 2 steps forward, 1 step back, 3 steps forward, 1 step back. And then once you launch that tool, now it'll be like in your dashboard. Oh, didn't like that one, huh? Oh no. Mine's giving me issues. I don't know if anybody else is having trouble. I don't think we would cause a DDoS attack, but it could be same thing. Interesting. But it's possible that maybe we just had too many people trying to log in all at once, because I did just have 75 people log in, and now we're having another 75 log in. Oh, is NanoHub in general? Is anyone on the NanoHub website? All right, so you're actually in. Some people are in. I'm getting kicked out, telling me that you can't even reach like nanohub.org. Why not? All right, okay. Pretend like things are going well, right? All right, so I'll check in, see if anybody did get into the resource or the tool. I'm kicked out. That it can't reach. Yeah. Can't reach. Okay. Yeah. Even just trying to get. Oh, you're in. Okay. So now you can go scroll down. Like you're in on your getting started. Is our first like assignment. Oh, but you create an account? Okay. And went to the email. Okay. On the website.
Yeah, I don't think that, don't use that institution. Like you can use a Google, like if you want a Gmail account, I think that one works. I try to use your credentials. It's out somewhere around. Oh, you did? Okay. Yeah.
Because I just use, just not turning on.
Oh, yeah.
I turned it on. Keyboard was like,
That one, you at some point,
it tries to say that she said, well,
like in your namespace, like the book might be an actual number. Like in that Excel balance, oh, because your volume equals volume. So you're overrating your value. That might be it. So you might have to rerun the definition of volume. Well, because you have to rerun, you have to redefine the value of wherever you create that function volume. Rerun that cell and try it.
oh, so I have to go here.
Yeah. Yeah. No. Right. So some people are in. You're at least one. It's weird. It almost seems like we had like 60% success last year. And it'll take a couple of seconds. Yeah, do that. Yeah. Then make a PDF of your. Yeah. I'm gonna try reloading and see if it's oh man, it really doesn't want to help me out today. Oh, and then it's really good. Yeah.
They did them downstairs. I don't know if they have today. I them downstairs. I don't think she's just too bad.
All right, so I'm running Jupyter like on my own computer, just so I can have something that we can work with. But I'll give one more college. No, it really just kicked me out of NanoHub. It's like, we're done with you. No more. But when you do get into NanoHub, there's a list of like, you end up like on a page like this home page, and then there's a list of all the stuff that you have that's in these modules. So you can click on the Getting Started, Module 0, Getting Started, and you'll end up in the same notebook in the classic interface. So if you hold Shift and hit Enter, it'll, wherever you are, it'll run. It's called execute, so it'll execute the cell and bring you to the next cell. And again, this is a lot of like just how to use Jupyter kind of stuff, but each one of these like blocks is called a cell. You can either have like text and like markdown text, so the same thing that you can use in the GitHub discussions. It'll work the same way in these text boxes. And then there are code cells, which are actual like Python code. So in a Python code cell, Shift Enter, it runs that cell. And in this first one, all it's doing is importing stuff, so it doesn't really show us anything. Like there's no output, no variables were defined. I mean, variables were defined, but didn't really do anything. So Shift Enter, let's get down to like some actual Python stuff. We can say 2 + 2. 1 1/4 + 3, 3 65ths. 2 × 4, 7/2. Do you know what this 7/2 does? What is that one? Yeah.
It gets rid of the flow and turns into an integer.
Yeah. Yeah, so it does the division, but it gets rid of all the extra floating point stuff. So why is it giving us 3 here? Shouldn't 3 1/2 round up to 4? Yeah.
It floors it, so it takes like just the first number rather than rounding it up or down.
Yeah. So it's giving you like, if you were doing long division, it gives you that first step before the remainder stuff. Do you know what a % sign would do?
The modulus.
The modulus, which is what's
like
that?
The remainder.
Yeah, the remainder. So what would this one be? 7% 2. What's the remainder? It's 3 remainder what?
Would just be the
1/2. 1/2? Is it 1/2? 1? Let's find out. 1. Yeah. So it's 3 remainder 1, and then that 2 gives us like 3 + 1/2. So if we wanted, we could say like print 7 over 2 is I'm just doing some fancy print commands. It's 3 remainder 1. Anyway, we can do all sorts of cool stuff in Python. Just depends on what we want to do. All right, what about 9 to the 1/2? Square root 9. What's the square root of 9? 3. So why does it tell me square root of 9 is 4.5? Yeah, so because I didn't specify like where I wanted that 9 to the 1/2 to happen, like when it's gonna do everything one at a time. So it's taking 9 to the 1, then dividing by 2. Makes sense. But I mean, it kind of makes sense, but at the same time, it's like, God, listen to what I'm saying. Do what I want you to do, not what I tell you to do. So it's easy enough to fix, but we have to think about like, all right, what is happening? Like, how do I get this thing to do what I want it to when I want it to? Cool. And I'll skip over some of this because we just have a few minutes left. I have like this block of text here, or block of code. What is this doing? What am I doing here? Like, why am I setting all this up? Take a look at it. Think about it. Let me check in, see what people. And I know some of us are in Jupyter, others are just watching all of this happen. But we can still think about like what is this representing in terms of like things that we would do as engineers? What is this doing? Do you know what I'm trying to do? No. Do you recognize any of the numbers? Projectile motion? Yeah. Yeah, so it's like taking projectile motion and turning it into Python and graphing. Okay, yeah. So here I have like 0, 1, 2, 3, 4, 5. Those are seconds. And then trying to look at what the motion is for that time. Kinematic equation, yeah. Yep. Yes. Setting up some kind of like time. All right. So some things that people noticed. T is some kind of like time where I'm setting up like my time is going to be 0, 1, 2, 3, 4, 5. So it's, someone else said, hey, look, these look like kinematic equations, like for some kind of constant acceleration problem. Which one is which? Like what are the 2 accelerations that I have in these 2 kinematic equations? Because I'm defining like 2 different things. What's acceleration for x?
not have an acceleration? It only has like 20 different system.
Yeah, so acceleration is 0, right? So it's a kinematic equation for a equals 0. So whatever velocity it had to begin with, it's going to have that forever, like, until something else happens, until it's acted upon by an outside force, right? And then what's acceleration for this y variable? Yep.
Acceleration due to gravity.
Gravity, yep. So what is gravity in this? So we have g, what is it written at? What is g? Yeah, we got it. Now we have to like work backwards, right? Like, all right, we're dealing with meters per second and meters, seconds, these kind of units. So I'm setting up some initial values and saying that in the y direction, so in this case we would roughly think, looking at this block, y is kind of up-down motion, x is left-right motion, and we have some initial x, some initial y, and now we're looking at maybe how far this thing moved. It's 0, 1, 2, 3, 4, 5. Did anyone else notice something? Those are just the things that people kind of picked up on, like what we're doing here. So like when I run that block of stuff, nothing really happens, right? Because all I did was say, all of these are variables and I want to save them. I want to be able to use those variables again. So now I have an x, I have a y. They're defined at different points in time. I can look at them. So because I was initially moving 16 meters per second, 0 seconds is 0. 1 second, 16, 2, 32, 48, 64. So it's moving 16 meters every second. And then y, now at 0 seconds, it's starting at 1.2 meters. So this is, how tall is 1.2 meters? I know we're all like, not all of us, but a lot of us are more of feet and yards, cubits. Is anybody a cubit measurer? This distance, 1 cubit. But how tall is 1.2 meters? Is this a building?
Like 3 feet, 3.2 feet.
Well, yeah, 3 and a little bit more, right? Yeah. Yeah, 3. So it's something maybe like 4 feet, something like that. So like throwing a ball, like, side arming it. I guess, I mean, we could say like times 3, just take, or whatever, it's like 3 point something feet, right? But we could look at it. So it's starting about 4 feet and then going up and then coming back down. And then cool part is we can like, once we define that stuff, now we can plot it, like actually look at what's happening and then start to ask questions about like, all right, well, if I was 4 feet off the ground, I'm probably not going to end up at like negative 30 feet below the ground unless I'm throwing it off a building or something. Then you're calling the top of the building 0 and bottom is now negative something. So maybe I want to work on a problem like that. But right now, so if I'm trying to figure out when did this hit the ground, it's got to be somewhere between here and here, right? Because 0 is like this line. So 0 happens somewhere in here. So maybe I want to add more points in time. Time is always like an independent variable. So I can define time to be whatever I want. 0 to 10, 0 to 0.001, and I can make as many steps in time as I want. So maybe I'll make like 51 steps to go from 0 to 5, like add an extra 10 steps in between 0 to 1, 1 to 2. Redefine my positions, and now it looks like it hits the ground like right around there, so I can get better approximations for where this thing is going to hit the ground, like more information there. Anyway, that's our quick. And so what I've been doing here is like using arrows and shift enter. You can also use that. There's a triangle with a little button that says run. You can use that to like run that code, but play around with it. Breaking things is always better. We'll figure out how to fix it. So try stuff, break it, then next time we'll look at the problems at the end.